Space probes with sophisticated instruments are frequently sent to the planets of our solar system. They provide close-up investigations of these distant places. Hubble too provides its own unique service by opening a window on our solar system that is never closed. We've gained unprecedented views of storms on other planets, their changing seasons. And unprecedented views of other atmospheric events, such as aurorae, known on Earth as the Northern and Southern Lights. Even though the solar system clearly has many more surprises in store for us, Hubble has also turned its eye out towards other stars looking for planetary systems. Astronomers are beginning their search for life elsewhere in the universe. To start with, they are concentrating on finding Earth-like planets. In 2001, Hubble made the first direct detection of the atmosphere of an extrasolar planet and partially determined its composition. Measuring the chemical makeup of extrasolar planetary atmospheres will one day allow us to search for the markers of life beyond Earth. All living things breathe, and this changes the composition of the atmosphere in readily detectable ways. Astronomers believe there are many planetary systems similar to ours, orbiting other stars throughout the galaxy. The birth, life, death, and rebirth of stars continues in an unending cycle, in which stars born of gas and dust will shine for millions or billions of years, die and return as gas and dust to form new stars. The byproducts of this continual process include planets and the chemical elements that make life possible. So throughout the entire vastness of space, the eternal ebb and flow of life continues. Our Sun, that vital source of energy for life on Earth, is a star, a totally unexceptional star, just like billions of others that we can find throughout the galaxy.
A star is nothing but a sphere of glowing gas. It forms out of a compressed cloud of gas and releases energy steadily throughout its life because a continual chain of nuclear reactions takes place in its core. Most stars combine hydrogen atoms to form helium through the process called nuclear fusion, the same process that powers a devastating hydrogen bomb. In fact, stars are nuclear factories that convert lighter elements into heavier elements in a series of fusion reactions. They will keep glowing until they run out of fuel. And that's it, a star's life, a quiet beginning and a steady progress to a sometimes violent end. But how can we be certain of this picture when an individual star like the Sun outlives humans by a factor of a few 100 million?
To investigate the life cycle of a particular organism on Earth, we don't have to track an individual specimen's entire life. Instead, we can observe many of the organisms at once. This will show us all the different phases of its life cycle. For example, each stage of a person's life is a snapshot of the human experience. And so it is with stars.
Stars live and die over millions or even billions of years. Even the most reckless stars live for at least 1 million years, longer than the entire history of humankind. And that's why it's extremely difficult to track age-related changes in individual stars. To learn more about them, we must study different stars at every stage of life, and so piece together the entire cycle from birth to death. Hubble's vivid images have documented the tumultuous birth of stars and delivered many astonishing images in colourful detail.
The birth of stars in neighbouring stellar maternity wards can be used as a time machine to replay the events that created our solar system. Hubble has often had to work hard for this information, because these important clues about our genesis lie hidden behind the veil of gently glowing, dust-laden molecular clouds where stars are formed. There are stars forming everywhere in the universe. Enormous glowing pillars of dusty hydrogen gas stand sentinel over their cradles, basking in the light of nearby newly formed stars.
Hubble's ability to observe infrared light enables it to penetrate the dust and gas and reveal the newly born stars as never before. One of the most exciting of Hubble's many discoveries was the observation of dust disks surrounding some newborn stars buried deep inside the Orion Nebula. Here we are actually seeing the creation of new solar systems where planets will eventually form, just as they did in our own solar system 4.5 billion years ago. In the first stages of their lives, stars can stock up on gas from their original birth cloud. Material falling onto the star creates bubbles, or even jets, as it's heated and blasted out along a path that follows the star's rotation axis, a bit like the axis through a wheel.
Often, many stars are born from the same cloud of gas and dust. Some may stay together through their whole lifetime, keeping step as they evolve, like childhood friends that you keep for life. The stars in a cluster will all have the same age, but will have a range of different masses, and this means that very different destinies await them. Human existence is the mere blink of an eye compared with the life of a star. So the direct observation of a transition between different stages of a star's life can only come about by lucky chance. In 15 highly productive years, Hubble has allowed us to observe some stars aging in real time. The telescope has produced startling movies that allow us to witness how some of them do modify their appearance over this minute span of astronomical time. The stars containing the most mass end their lives cataclysmically,